This is Unit 1 and Part A, Section A. The first thing that we're learning is we want to be able to identify angle pairs that are congruent or equal, and we'll use what we know about parallel lines and angles to be able to decide when angles match or they're congruent. Let's talk about what congruent angles are just a little bit more. Congruent might be a new word for some of you, and when you see that word congruent, I want you to think exact, the same exact measure. Another way that you can think of this is equal, all right? Angles with the same exact measure. And the notation that we use, remember we use little symbols in math. Here's the notation that we use to say congruent. If we want to say that they are not congruent, we just add a little word, not, in front of that symbol. And you'll see that soon in your homework and in the notes. Let's sketch a picture of some congruent angles. Well, here's an angle. We'll call this angle A. And we like to add a little symbol like that. And that indicates that the measure of that angle. Let's say that this angle is 79 degrees. And we'll have a second angle. We'll call this angle angle B. And this angle also is 79 degrees. And because those two angles measure the same thing exactly, we say that angle A, here's the notation for angle, is congruent to angle B. Another type of angle, they are supplementary angles. Supplementary angles are defined as angles that have a sum. They add up to 180 degrees. And the most common time that you will see supplementary angles, we'll see in two different places. One is, and again, probably the most useful for us for this unit, when you have angles on a straight line. Here's our straight line, and here's one angle here, and then we have another angle right next to it. You can see that they take up a whole line, okay? We'll call this angle C and this angle D. Let's say angle C, we'll just color this in pink. Sometimes it's going to help us to have colors for our angles so that we can just see a little bit more plainly what's happening. Angle D will make blue. You can see that if we're taking up both angles, they're going to be a half of a circle. And whenever you have angles on a straight line like that, angle C here plus angle D, when we add those angles up together, they will always equal 180 degrees. And that's our definition for supplementary angles. So angles on a straight line, that's one of the times that we'll see angles adding up to 180 degrees. And the other time is whenever we have parallel lines. Here's our parallel line symbols or indicators. We have a line that passes through. These two angles on one side of our transversal, and on the inside of those parallel lines, those also add up. We'll call this angle E. We'll call this one angle F. And angle E plus angle F is going to equal 180 degrees. So here are two examples of supplementary angles that we are going to see in this unit. Our next definition is vertical angles. Vertical angles happen anytime two lines intersect. And you can see that when two lines intersect, we have four angles that form. Each of these represents the angle there. And what we know about vertical angles is that when they're directly opposite, when these angles are opposite each other, that's when we have vertical angles. That's a vertical angle, okay? Is that they are right across from each other when we have an intersection like this. They're diagonal. They're not next to each other, right? They're opposite from each other. So the yellow angles, or we'll call these G, and this angle J, we'll call this angle K. Okay, so angle G is congruent to angle J because they are vertical angles. So by definition, all opposite angles that are formed from two lines that intersect or cross, by definition, they are always congruent. Now remember what congruent means. That means angles with the same exact, not about, but exact measure, the same exact measure. Well, if angle G and angle J match exactly, well, we also know that angle H and angle K, they're also directly opposite from each other at an intersection where two lines are crossing. And we know that angle H is also congruent to angle K. Okay? These, again, are called vertical angles, and this is a very important principle. Okay? Always, those two opposite each other will match or are congruent. Let's do example 1. Example 1 shows us two lines that are crossing. Now, this looks a bit like this picture, doesn't it? I think it's useful when we see an intersection like this where two lines are crossing to draw a circle around that intersection so we can see our angles. There's 1, 2, 3, and 4. It's a little bit easier. Well, I also think it's very useful to color in angles. So let's go ahead and do that. This angle here, we already know measures 100 degrees, okay? We know that this angle opposite, then, because those are vertical angles, will also be 100 degrees. And this angle next to it and the one opposite it are also matching, but we don't know how much it measures, right? What we do know is that when we have two angles and they make up a straight line, we call those angles supplementary. And supplementary angles always add to 180. Okay? And one of the telltale signs that we have angles that add to 180 is those are angles on a straight line. Okay? So that's what we have here. And the way that we always solve a problem like that is we'll start off saying, well, angles on a straight line add to 180. I know that that's how much added together they'll make. And then you're going to subtract the number of the angle that you're given, the size of the angle that you know. And when we do that, we're going to have 80 degrees left over. And that way we know that this little angle has to equal 80 degrees because together 100 plus that small 80 degree will give us 180. And that's what angles on a straight line always equal. So if this little guy is 80 degrees, so is this angle. And when we write it in our answer blanks over here, I want you to notice that this little m means measure, the measure of angle. And here's the way that we're stating the name of these angles over here. We'll use those endpoints first, and then that vertex in the middle, which is P. P is our vertex. That's right in the middle. And that vertex, the label for the vertex, always will go in the middle when we're talking about angles. So the measure of angle KPH will start here at the endpoint K. PH is going to equal 80 degrees. LPH, here's our L. Then there's PH, okay, the endpoints. And then here's that angle in the middle is 100 degrees. GPL, here's GPL, 80 degrees again. And that's how we work example 1. Now let's look at the definition of parallel lines. We know that parallel lines are two or more lines that never intersect. That's our definition for parallel lines. And the notation, a little shortcut way to write that would be to draw little mini parallel lines. Okay, that's what they look like. We also include marks when lines are parallel, and they look like this. Little parallel line indicators. Those are marks telling us those two lines are parallel. And you'll see them down on our figure here. There's our little parallel line markings telling us these two lines are parallel. Now look over here. Are these lines parallel? Well, it says these lines are not parallel. So you know that, but if you were to imagine those lines continuing on, you could see that eventually they would touch or cross. Okay, so we know that these are not parallel lines. The other definition that I want you guys to be really familiar with is transversal. And here's two lines. When we have a line that passes through two other lines, we call that a transversal. Okay, that line intersects or crosses two other lines. And whenever it does, it's going to create intersections that have angles, 4 angles each. All right, so parallel lines and transversal, more vocabulary. Okay? We'll go ahead and finish the rest of our vocabulary on our next video lecture. Thank you.